Einstein, His Life and Universe, by Walter Isaacson. Introduction. Imagine for a moment you're 16 years old. You're sitting in class, perhaps a little bored, and you start to wonder. Not about what's for lunch, or the weekend, but about the very fabric of the universe. You ask yourself a question that no one else seems to be asking. What would it be like to ride alongside a beam of light? Would the light wave freeze beside you, like a shimmering, motionless ribbon of energy? Would time itself stop? This wasn't just a daydream. It was a thought experiment that sparked a revolution. It came from the mind of a young man who was once told by a schoolmaster that he would never amount to much. A young man who struggled to get a job, who failed his first college entrance exam, and who spent his most creative years as a third-class clerk in a patent office. His name, of course, was Albert Einstein. Today, we're going to journey through his incredible life, as captured in the masterful biography, Einstein, His Life and Universe, by Walter Isaacson. This isn't just a story about physics and equations. It's the story of a rebel with a cause. A man whose wild halo of hair and twinkling eyes became a symbol for genius itself. But what is genius? Is it about having a brain that works faster than anyone else's, or is it something deeper? By the end of our time together, you'll discover the true wellspring of Einstein's creativity. It wasn't just about being smart. It was about his passionate curiosity, his defiant imagination, and his willingness to question everything everyone else took for granted. He teaches us that the most powerful tool we have is not our knowledge, but our ability to wonder. This is the story of how a patent clerk unlocked the secrets of the cosmos and became the conscience of the world. It's a testament to the idea that true genius lies not in having all the answers, but in never losing the courage to ask the most fundamental questions. So, let's begin. Let's ride alongside that beam of light and see where it takes us. Book summary. It's funny, the stories we tell about our heroes. One of the most common tales about Albert Einstein is that he failed math in school. You'll hear it everywhere, often told to reassure students who are struggling. Don't worry, they'll say, even Einstein failed math. It's a wonderful story. But it isn't true. In reality, Einstein was a brilliant student, especially in math and science. By the time he was 15, he had already mastered differential and integral calculus on his own. The myth of his failure comes from a misunderstanding of the German grading system, but the truth is far more interesting. His real struggles weren't with the subjects themselves, but with the way they were taught. From a young age, Albert Einstein was a rebel. He was born in Ulm, Germany, in 1879, to a middle-class Jewish family that was more focused on culture and education than on religious rituals. He was a slow talker, so slow that his parents worried and even consulted a doctor. When he finally did speak, he had a curious habit of whispering every sentence to himself before saying it out loud. The family maid called him the dopey one. But this slow development was paired with a fierce independence of mind. He hated the rote memorization and rigid discipline of the German schools. He couldn't stand the military-style drills or the demand for unquestioning obedience. One teacher famously told him that his smiling presence in the back of the classroom undermined the respect of the entire class. Another declared that he would never amount to much. For most people, this constant friction with authority would be a crushing burden. For Einstein, it became his greatest strength. His contempt for authority wasn't just teenage rebellion, it was the foundation of his scientific genius. It gave him the courage to question the most deeply held beliefs in physics, ideas that had stood unchallenged for over 200 years. He later believed his slow verbal development was actually a gift. While other children quickly learn about concepts like space and time and then take them for granted, Einstein came to these ideas late, with a fresh sense of wonder. He never stopped being a curious child before the great mystery into which we were born. That sense of wonder was ignited by a simple gift. When he was about 5 years old and sick in bed, his father brought him a compass. As he watched the needle tremble and point unfailingly north, he was mesmerized. There was no string, no visible force pulling it. It was responding to an invisible field that filled the space around it. He recalled feeling a deep and lasting impression, a sense that something deeply hidden had to be behind things. That single moment sparked a lifelong fascination with field theories, the idea that the universe is governed by invisible forces that shape reality. It was a mystery he would spend the rest of his life trying to solve. His mother, an accomplished pianist, gave him another gift that would shape his mind, a violin. At first, he hated the disciplined lessons. But when he discovered the sonatas of Mozart, music became a passion. It wasn't just a hobby, it was a way of thinking. He saw in the pure, logical structure of Mozart's music a reflection of the harmony of the universe itself. Throughout his life, when he was stuck on a difficult problem, he would take out his violin. He would play, and in the middle of a melody, an idea would come to him. It was as if music, nature, and the mind of God were all connected, speaking the same beautiful language. His rebellious spirit finally came to a head at 15. His father's electrical business had failed, and the family moved to Italy, leaving Albert behind in Munich to finish his schooling. He hated it. He felt trapped, depressed, and intellectually stifled. So he hatched a plan. He got a doctor's note saying he was suffering from nervous exhaustion, left school at Christmas, and took a train across the Alps to join his astonished family. He promised them he would study on his own and get into the prestigious Zurich Polytechnic. This wasn't just about escaping a bad school. It was about escaping the militaristic, authoritarian culture of Germany. Had he stayed, he would have been forced into the army, a prospect he dreaded. He renounced his German citizenship and, for a time, was stateless, a citizen of the world. His first attempt to get into the Zurich Polytechnic was a failure. He aced the math and physics sections, but failed the parts on general subjects like French and literature. On the advice of the director, he spent a year at a special high school in the village of Aarau, Switzerland. It was a life-changing experience. The school in Aarau was the complete opposite of his German gymnasium. It was founded on the philosophy of encouraging students to visualize images, to think for themselves, and to learn through intuition and observation rather than rote drills. For Einstein, it was paradise. It was here that he first performed the thought experiment that would set him on the path to his greatest discovery. He asked himself that famous question, what would it be like to ride alongside a beam of light? According to the prevailing theories of the time, a light beam was an electromagnetic wave rippling through a mysterious, invisible substance called the ether. If you could travel at the speed of light, you should be able to see a frozen, stationary wave of light beside you. But that seemed impossible. It violated his intuition that the laws of physics should look the same for everyone, no matter how they were moving. This paradox, this psychic tension, would stick with him for the next 10 years. In Aarau, he also found something else he had been missing, a warm, loving home. He boarded with a Wintler family, and they embraced him as one of their own. He fell in love for the first time with their daughter, Marie. He became more personable, more open, and even developed a witty, sarcastic sense of humor that charmed his friends. After a year, he finally passed his exams and enrolled at the Zurich Polytechnic in 1896. He was supposed to become a teacher, but his old habits of skipping class and disrespecting professors returned. He found the lectures outdated. They didn't even cover the groundbreaking work of James Clerk Maxwell, whose elegant equations described how light, electricity, and magnetism were all connected as electromagnetic waves. So Einstein taught himself. He and a small group of friends would gather in cafes, reading the latest papers in theoretical physics and debating the biggest ideas in science and philosophy. They called themselves the Olympia Academy. It was during these late-night sessions, fueled by coffee and cigars, that Einstein honed his thinking, questioning the very foundations of physics. He had a close friend, Marcel Grossmann, a brilliant and diligent math student who took meticulous notes that he shared with the often absent Einstein. "Without these books," Einstein later said, "I would rather not speculate on what I would have done." Their friendship would prove crucial not once, but twice, in Einstein's life. During his time at the Polytechnic, his relationship with Marie Wendler faded. He had moved on. He had fallen in love with the only other physics student in his section, a brilliant, intense, and brooding Serbian woman named Mileva Mori. She was 3 years older, walked with a slight limp, and was prone to melancholy, but she shared his passion for science and his rebellious spirit. They were intellectual soulmates. "How happy and proud I will be," he wrote to her, "when the two of us together will have brought our work on relative motion to a conclusion." Their romance was stormy and passionate. His parents, especially his mother, fiercely disapproved of Mileva. They saw her as too old, too intellectual, and not even Jewish. But their opposition only fueled Einstein's rebellious love. He and Mileva had a child out of wedlock, a daughter named Liesel, whose existence was a secret kept for decades. Einstein likely never saw her, and her ultimate fate remains one of the sad mysteries of his life. She was probably given up for adoption in Serbia and may have died of scarlet fever as an infant. When Einstein graduated from the Polytechnic in 1900, he was near the bottom of his class. His professors, annoyed by his impudence, refused to recommend him for any academic positions. He was the only graduate in his section who wasn't offered a job. For 2 years, he drifted, taking temporary tutoring jobs, feeling like a failure. "I am nothing but a burden to my family," he wrote in despair. "It would be better off if I were not alive at all." It was his friend Marcel Grossmann who saved him. Grossmann's father knew the director of the Swiss patent office in Bern, and he recommended Einstein for a position as a technical examiner. In 1902, Einstein finally got the job. It seemed like a dead end for a man who dreamed of unraveling the cosmos. But the patent office turned out to be a blessing. The work was interesting, forcing him to think about the nature of space, time, and light as he evaluated patents for synchronizing clocks with electromagnetic signals. And he was so good at it that he could finish his daily work in just a few hours, leaving the rest of the day to work on his own ideas at his desk, which he famously called his worldly cloister. It was there, in his spare time, that Albert Einstein had one of the most productive years in the history of science. The year was 1905, his annus mirabilis, or miracle year. He was 26 years old. He produced 5 papers that would change the world. The first, and the one he considered his most revolutionary, tackled the nature of light. The physicist Max Planck had recently suggested that energy might be emitted or absorbed in discrete packets, which he called quanta. But he saw this as a mathematical trick, not a physical reality. Einstein took it a step further. He proposed that light itself is not a continuous wave, but is made of these tiny packets of energy, which we now call photons. This idea could explain the photoelectric effect, where light hitting a metal surface knocks electrons loose. It was a radical idea that laid the foundation for quantum theory, and it was so strange that it would trouble Einstein for the rest of his life. The second and third papers were related. They provided a way to determine the true size of atoms and molecules, and they explained Brownian motion, the strange, jittery dance of microscopic particles suspended in a liquid. By showing that this dance was caused by the random collisions of unseen water molecules, Einstein provided the first convincing experimental proof that atoms and molecules actually exist. At the time, their existence was still a matter of debate. The fourth paper was the one that finally solved the paradox that had been haunting him since he was 16. It was titled On the Electrodynamics of Moving Bodies, and it introduced the world to the special theory of relativity. In it, Einstein threw out the centuries-old ideas of absolute space and absolute time. He started with two simple postulates. First, the principle of relativity. The laws of physics are the same for all observers in uniform motion. This was an idea that went back to Galileo. Second, the light postulate. The speed of light in a vacuum is constant for all observers, regardless of their motion or the motion of the light source. These two ideas seem to contradict each other. How could the speed of light be the same for someone standing still and for someone chasing after the light beam at nearly the speed of light? The solution came to him in a flash of insight during a conversation with his friend and patent office colleague, Michel Besso. The key, he realized, was to rethink the concept of time. Our notion of simultaneity is not absolute. Two events that appear to happen at the same time to one observer might appear to happen at different times to another observer who is moving relative to the first. He used a thought experiment. Imagine two lightning bolts striking a train track at two distant points at the same time. An observer standing on the embankment exactly halfway between the strikes will see the light from both flashes arrive at the same instant. But for a passenger on a moving train, who is rushing toward one strike and away from the other, the light from the strike she is moving toward will arrive first. For her, the strikes are not simultaneous. And if simultaneity is relative, then time itself must be relative. A moving clock runs slower than a stationary clock. An object's length contracts in the direction of its motion. Space and time are not separate and absolute, they are interwoven into a single continuum, space-time. And with this, the mysterious ether that was supposed to fill all of space became, in Einstein's delightfully dismissive word, superfluous. Then, a few months later, as a kind of afterthought, he published a short, 3-page fifth paper. It was an addendum to his relativity paper, and it contained what would become the most famous equation in all of science, $E equals mc squared $. Energy equals mass times the speed of light squared. This simple formula revealed a profound truth: mass and energy are two different forms of the same thing. Mass is simply a highly concentrated form of energy. Because the speed of light squared is such an enormous number, a tiny amount of mass can be converted into a tremendous amount of energy. The energy locked inside a single raisin could power New York City for a day. In one incredible year, a young patent clerk had redrawn the map of the universe. But the world barely noticed. His papers were met with what he called an icy silence. He still couldn't get an academic job. For 4 more years, he remained at the patent office, continuing his work in his spare time. Slowly, though, the giants of physics began to take notice. Max Planck, the grand old man of German science, was the first to recognize the importance of relativity and began to lecture on it. The recognition was welcome, but Einstein was already moving on. Special relativity was incomplete. It dealt only with uniform, constant velocity motion. It didn't account for acceleration, and it didn't incorporate gravity. Then, one day in 1907, while sitting in his chair at the patent office, he had what he would later call the happiest thought of my life. He imagined a person in free fall, perhaps a painter falling from a roof. During the fall, that person would not feel his own weight. He would be weightless. An object released from his hand would float beside him. Einstein realized that the experience of being in a gravitational field is indistinguishable from the experience of being in an accelerated frame of reference. This was his principle of equivalence. Imagine you're in a windowless elevator in deep space, far from any gravitational pull. If the elevator is accelerated upwards, you will feel yourself pressed to the floor, just as you would by gravity on Earth. If you drop a ball, it will fall to the floor. There is no experiment you could perform inside that elevator to tell whether you are being accelerated or are simply sitting in a gravitational field. This simple, beautiful insight was the key to a new theory of gravity. But turning this happiest thought into a complete theory would be the hardest struggle of his life. It would take him 8 more years of intense, grueling work. The math was so complex that he needed the help of his old friend, Marcel Grossman, the one who had taken notes for him in college. "Grossman," he said, "you must help me, or I will go crazy." Grossman introduced him to the complex world of non-Euclidean geometry, the mathematics of curved surfaces. Einstein's breathtaking leap of imagination was this: gravity is not a force that pulls objects across space, as Newton had thought. Instead, gravity is the curvature of space-time itself. The best analogy is to picture a bowling ball placed on a trampoline. The fabric of the trampoline curves around the heavy ball. If you then roll some billiard balls nearby, they don't move toward the bowling ball because it's exerting some mysterious force on them. They move toward it because they are following the curves in the fabric of the trampoline. Now, imagine this happening not on a 2-dimensional trampoline, but in the 4-dimensional fabric of space-time. Massive objects like the Sun warp the space-time around them. Planets like Earth orbit the Sun not because they are being pulled by a force, but because they are following the straightest possible path through this curved space-time. The quest to find the precise mathematical equations to describe this cosmic dance was a race. He was competing against one of the greatest mathematicians in the world, David Hilbert. In a frantic, 4-week burst of creativity in November 1915, working in Berlin amid the turmoil of a world war and the collapse of his own marriage, Einstein finally found the solution. One of the theory's predictions was that it could explain a tiny, mysterious wobble in the orbit of the planet Mercury that Newton's laws could not. When his calculations produced the exact right number, he was so excited he had heart palpitations. "I was beside myself with joyous excitement," he told a friend. He had done it. The general theory of relativity was his masterpiece, one of the most beautiful and profound achievements of the human mind. It had another testable prediction: because gravity curves space-time, it should also bend light. A ray of light from a distant star passing near the Sun should be deflected by a precise amount. This prediction was put to the test in 1919. A British astronomer, Arthur Eddington, led expeditions to Brazil and an island off the coast of Africa to photograph a total solar eclipse. When the stars became visible near the Sun's edge, their positions were measured. They had indeed shifted by the exact amount Einstein's theory had predicted. The announcement made headlines around the world. "Revolution in Science," declared the Times of London. "Newtonian ideas overthrown." Albert Einstein, the obscure patent clerk, was suddenly the most famous scientist in the world. He became an icon, a global celebrity. His face was everywhere. His name became a synonym for genius. His personal life was just as turbulent as his scientific one. His marriage to Mileva had disintegrated. She had been his intellectual partner in his youth, but she grew increasingly morose and jealous as his fame grew and her own scientific dreams faded. In 1919, they divorced. In a remarkable act of confidence, he offered her a deal. He promised her the money from the Nobel Prize he was sure he would one day win, if she would grant him the divorce. She accepted. It took 2 more years, but in 1922 he was awarded the Nobel Prize, not for relativity, which was still considered too controversial, but for his explanation of the photoelectric effect. Mileva got the money. He had already remarried, to his first cousin, Elsa Einstein. She was the opposite of Mileva, nurturing, domestic, and unimpressed by intellectual complexities. "Understanding relativity," she once said, "is not necessary for my happiness." She was his protector, his manager, his gatekeeper, creating a comfortable bourgeois home that allowed the rumpled, absent-minded professor to retreat into his own world of thought. As his fame grew, so did the darkness in Germany. The rising tide of anti-Semitism, which had always been an undercurrent in his life, now became a dangerous force. Attacks on him and his Jewish physics grew more frequent and vicious. This had a profound effect on him. Though never religious in a traditional sense, he began to embrace his Jewish identity with a newfound passion. He became an outspoken supporter of Zionism, not because he believed in nationalism, he hated it, but because he saw the need for a homeland where Jews would not be considered aliens. In 1921, he made his first trip to America, not to lecture on physics, but to raise money for the cause with the Zionist leader Chaim Weizmann. The trip turned him into an American sensation. But it was this period, in the mid-1920s, that marked the great turning point in his scientific life. The quantum revolution he had helped to launch was now being transformed by a new generation of brilliant young physicists: Werner Heisenberg, Erwin Schrödinger, Wolfgang Pauli, and their mentor, Niels Bohr. They were developing a new quantum mechanics based on uncertainty, probability, and chance. And Einstein hated it. He could not accept that the universe, at its most fundamental level, was governed by randomness. The idea that an electron could choose, of its own free will, when to jump from one energy level to another, or which direction a photon would be emitted, was intolerable to him. This led to his most famous declaration of faith: "I, at any rate, am convinced that he does not play dice." This began the great intellectual debate of the 20th century, a series of legendary arguments between Einstein and Niels Bohr. At conferences and in letters, Einstein would devise ingenious thought experiments designed to poke holes in quantum mechanics, to show that it was incomplete. The most famous of these was the EPR paper, written in 1935 with his colleagues Boris Podolsky and Nathan Rosen. They imagined two particles that interact and then fly off in opposite directions. Because their properties are correlated, measuring a property of one particle, like its position, could instantly tell you the position of the other, no matter how far away it was. This seemed to imply what Einstein mockingly called spooky action at a distance. How could measuring one particle instantaneously affect another 1 billions of miles away? It violated his deeply held beliefs in locality, that an event here cannot instantly affect an event over there, and in an objective reality that exists independent of our observations. Inspired by these debates, Erwin Schrödinger came up with his own famous thought experiment to illustrate the absurdity, the paradox of Schrödinger's cat. A cat is placed in a box with a vial of poison that will be released if a single radioactive atom decays. According to quantum mechanics, until the box is opened and observed, the atom is in a superposition of being both decayed and not decayed. Does that mean the cat is also in a superposition of being both dead and alive? For Einstein, this was proof that quantum mechanics was not a complete description of reality. Bohr and his followers, however, argued that Einstein was wrong. The spooky action was real. The universe is that strange. And experiment after experiment, to this day, has proven Bohr right and Einstein wrong. The great revolutionary had become a resistor. The man who had overthrown the certainties of classical physics now dedicated the last 30 years of his life to trying to restore them. He embarked on a long, lonely, and ultimately unsuccessful quest for a unified field theory, a single set of equations that could describe all the forces of nature, gravity and electromagnetism, and explain the existence of particles and the strangeness of the quanta in a deterministic, orderly way. He was searching for the mind of God. As he was losing the battles in physics, the political battles in the world were becoming more terrifying. In December 1932, as he was preparing to leave for a visit to California, he said to Elsa as they left their beloved country cottage outside Berlin, "Take a very good look at it. You will never see it again." He was right. A month later, Adolf Hitler came to power. Einstein's house was raided by the Nazis, his books were burned, and a bounty was placed on his head. He never set foot on German soil again. He became a refugee, a symbol of the intellectual and moral destruction wrought by the Nazis. He eventually settled in Princeton, New Jersey, at the newly formed Institute for Advanced Study. He had found his final home. The rise of Hitler also forced him to confront his lifelong pacifism. "As long as I have any choice in the matter," he had always said, "I shall live only in a country where civil liberty, tolerance, and equality of all citizens before the law prevail." Those conditions no longer existed in Germany. He realized that against such evil, pacifism was not an option. "I am not only a pacifist, but a militant pacifist," he had once declared. But now, he urged the nations of Europe to arm themselves against the Nazi threat. It was a painful but necessary change of heart. Then came the letter that would haunt him for the rest of his life. In the summer of 1939, his old friend, the Hungarian physicist Leo Szilard, came to visit him on Long Island. Szilard and other refugee scientists were terrified that German scientists were on the verge of discovering how to build an atomic bomb. They needed to warn the American government, but they knew no one would listen to them. They needed a voice that could not be ignored. Einstein dictated a letter to President Franklin D. Roosevelt, explaining the possibility of a nuclear chain reaction and the potential for extremely powerful bombs of a new type. He signed it. The letter was delivered to Roosevelt, and it helped to launch the Manhattan Project. Einstein himself was never asked to work on the bomb. The FBI, under J. Edgar Hoover, had compiled a massive and largely ludicrous file on him, labeling him a security risk because of his pacifist and socialist leanings. He knew nothing about the project until he heard the news on the radio in August 1945 that a bomb had been dropped on Hiroshima. He was horrified. "Oh my God," was all he could say. He later called the letter to Roosevelt the one great mistake of his life. "Had I known that the Germans would not succeed in producing an atomic bomb," he said, "I would not have lifted a finger." For the last decade of his life, he became a passionate advocate for nuclear arms control and world government. "The unleashed power of the atom has changed everything save our modes of thinking," he warned, "and thus we drift toward unparalleled catastrophe." He knew that nationalism was now a suicidal folly. The only salvation, he believed, was a supranational authority with the power to prevent war. He also became a fierce defender of civil liberties in his adopted country, speaking out against the Red Scare and the McCarthy-era witch hunts. He saw the intimidation of intellectuals and the demand for political conformity as a frightening echo of what he had seen in Germany. He advised people who were called before congressional committees to refuse to testify, an act of civil disobedience that brought a storm of criticism down upon him. But he remained unbowed. Freedom of thought, he believed, was the lifeblood of a healthy society. He lived out his final years in the quiet town of Princeton, a living landmark, a gentle, rumpled figure with a booming laugh who would help local children with their math homework. He had grown closer to his son, Hans Albert, who became a respected engineering professor. But he was haunted by the tragic fate of his younger son, Edward, who spent his life in a Swiss asylum with schizophrenia. Einstein never saw him again after leaving Europe. His last public act was to sign a manifesto with the philosopher Bertrand Russell, urging all nations to renounce nuclear weapons. He died a week later, in April 1955, at the age of 76. By his bedside were 12 pages of equations, his final, unfinished attempt to find his unified field theory. He died as he had lived, still searching, still wondering. Commentary. So what do we take away from this incredible life? What are the lessons that Albert Einstein, this gentle rebel who remade our universe, has to offer us today? It seems to me there are a few simple, yet profound, truths that shine through Walter Isaacson's magnificent biography. First, and perhaps most importantly, is the power of curiosity. Einstein often said he had no special talents, only that he was passionately curious. Think about that. He didn't see himself as a superhuman intellect, but as someone who never lost that childlike sense of wonder. He questioned the things that adults learn to take for granted. Why does a compass needle point north? Why is the sky blue? What would it feel like to ride on a beam of light? He shows us that the greatest breakthroughs don't always come from having the most knowledge, but from asking the most fundamental questions. It's a powerful reminder to never stop asking why. The second lesson is the courage of nonconformity. Einstein's entire life was an act of rebellion. He rebelled against the rigid discipline of his German schools. He rebelled against the stuffy conventions of the academic world. He rebelled against the common sense of physics that had been accepted for centuries. His genius was inseparable from his willingness to be an outsider, to think differently, to sail against the current. In a world that often pushes us to fit in, to follow the rules, Einstein's life is a powerful argument for the creative power of being a little different, of marching to the beat of your own drum. But his rebellion wasn't destructive. It was what Isaacson calls a reverential rebellion. This is the third great lesson. He could tear down the pillars of Newtonian physics, but he did so with a deep, almost religious, awe for the harmony and beauty of the universe. He believed in an underlying order, a spirit vastly superior to that of man. This combination of rebellious questioning and humble reverence is what made him so unique. He had the confidence to challenge the old, but the humility to be in awe of the mystery of it all. He wasn't just trying to be clever, he was trying to read the mind of God. And finally, there's the beautiful connection he made between imagination and reality. He didn't come up with his theories by poring over experimental data. He came up with them through pictures, through thought experiments, through what he called great forward leaps of the imagination. He could visualize what it meant for space to be curved, for time to be relative. For him, imagination wasn't just a fantasy, it was the language the universe was written in. As he famously said, imagination is more important than knowledge. For knowledge is limited, whereas imagination embraces the entire world. So, how can we apply these lessons in our own lives? It's simple, really. Stay curious. Ask the obvious questions. Don't be afraid to challenge conventional wisdom. And never, ever let go of your imagination. Nurture that sense of wonder you had as a child. Look at the world with fresh eyes, and remember that behind the everyday, there is a universe of mystery waiting to be discovered. That was a summary of Einstein, His Life and Universe by Walter Isaacson. We've touched on the major moments of his life and the core of his ideas, but a brief journey like this can only show you the highlights on the map. The real adventure comes from exploring the territory yourself. The beauty of Isaacson's book is in the rich details, the personal letters, and the intimate stories that bring this incredible man to life. If any part of this story has sparked your curiosity or made you wonder, I truly encourage you to pick up a copy. Reading it isn't just learning about a great scientist, it's an experience that can genuinely change the way you think about creativity, genius, and the universe we all share. You'll find a link to the book in the description below. Also, if you found this summary valuable, please take a moment to click that subscribe button. It helps us continue to bring you these deep dives into the books that have shaped our world. Let's keep learning, and keep wondering, together.